Hi, it's Brian again. Today we're going to look at confidence intervals in StatCrunch. First we're going to go back to that normal calculator and just first look at the first task that you're often asked for is finding critical z-values. When you're asked for a critical z-value, this notation z alpha over 2, what we're really talking about is it's just notation for this alpha represents the complementary probability. So this 87% confidence interval, the complementary amount of probability is 1 minus 87%. So when we say that it's 1 minus the 0.87, alpha corresponds to this 0.13. So alpha over 2 is 0.13 divided by 2. That's 0.065. So what we're looking at is a critical value from a normal probability distribution, which is going to leave 0.065 probability in each of the two tails. So I'll show you in a picture. Let's go to stat calculators, pull up the normal calculator. It's very easy to do in StatCrunch, and we don't have to deal with any of this alpha divided by 2 business. Excuse me. All we have to do is set our standard normal, since again we're doing a z value. That's a standard normal. That's a mean of 0 and a standard deviation of 1. So if we put in 0.87 as the probability, this is going to give us the cutoffs, which trap 87% in the middle. So consequently, we've got this 0.065 out in each of the two tails. So the cutoffs are right here, 1.5141. So we would round it to 1.51. And the z alpha over 2, this is the positive ones. Okay, so that's all we're asked for this critical z value. Okay, constructing a confidence interval is very, very easy in StatCrunch, as most of these tasks are. So to create a confidence interval, it's going to be under the Stat menu. If we're doing a proportion population confidence interval, this is going to be under proportion stats, one sample with summary. Since we're given the summary of how many people from our sample size of 250, 75 out of 250 said yes to some survey question. So we want to create a 90% confidence interval. So we just put in 75 for the number of successes, 250 for the number of observations, and we want to select confidence interval for P and set the confidence level to 90%. Keep the method at standard walled, no need to change that, and click compute. And we're going to get the lower limit and upper limit for a confidence interval. So I'll take the first 3 decimal places and copy them over. So we've got 0.0252 and 0.334 rounded up to 3.348. So what we would say is we're 90% confident that the true population proportion is between 0.252 and 0.348. Okay, so we want to now turn around and ask if we want to create a certain type of confidence interval. This researcher wants to estimate the percentage of adults who support abolishing the penny. Count me among those people, incidentally, but what size sample should be obtained if he wishes to estimate to be within 3 percentage points at a 95% confidence level? There's a tool for that in StatCrunch. It's found under the Stat menu. Under the proportion stats, one sample, you'll see this width/sample size tool. Okay, so what you do is you put in your confidence level, 0.90. Oh, sorry, it's 95. And the target proportion, this is, if we use a previous estimate of 0.36, that's what we put in for the target proportion. And now, here's the thing you have to be a little bit careful of. It asks you for the width, okay? And for the width, since we want to be within 3 percentage points, that's not the width, that's the margin of error. The width of the confidence interval is twice the margin of error. So instead of putting in 0.03, we put 0.06. We hit enter, and it's going to give us a sample size of 984. That's it. Now, what if we do not use a prior estimate? For proportion confidence intervals, if we have no prior estimate, we use the target proportion of 0.5. This is the widest the confidence interval can be. So again, I'm going to go back to, I'm going to just put it in again, 0.06 for my width, and it rounds it off in order to make the sample size a whole number. It goes up to the next biggest whole number, 1068. So you can see if you have an estimate of 0.5, or if you have no prior estimate, you need to have a larger sample size in order to guarantee a confidence interval no greater than 3 percentage points. Anyway, that's great. We have this super easy tool for calculating sample size for proportions. Okay, find the t-value such that the area to the right tail is 0.02 with 9 degrees of freedom. We don't want to use tables. There's a t distribution calculator in StatCrunch. So under the calculator menu, pull up the t distribution. Okay, now the t distribution well, it looks a little similar to the normal distribution, but the parameter is different. Instead of putting in a mean and a standard deviation, what you do is you put in a degrees of freedom. The t distribution always has a mean of 0, and it always has a standard deviation of 1. What the degrees of freedom do for the t distribution is it puts more probability out in the tails for a lower degree of freedom, and for a higher degree of freedom, it brings the probability into the center. So anyway, well, let's set the degree of freedom. We're asked for 9 degrees of freedom, so let's set that 9 degrees of freedom. We want the area in the right tail to be 0.02. So the right tail, we want the probably greater than or equal to some value to be equal to 0.02. This is the picture, and it gives us the cutoff. We'll take 3 decimal places, 2.398. No need to use a t-table. We want to find a t-value such that the area to the right on the right tail is 0.20 with 23 degrees of freedom. 23 degrees of freedom. We want the area to the right to be 0.20. Compute. Excellent. 0.857. Rounding up. 0.858. Find a t-value such the area to the left is 0.10 with 12 degrees of freedom. Hint, use symmetry. Don't worry about that. We don't need to use symmetry. We can just do it right into the calculator. The area to the left of the t-value is 0.10. We want 12 degrees of freedom, and we want 0.10. This is it. It's negative 1.356. Excellent. 95% confidence. Okay, now to find for confidence intervals, we'll use the between calculator. We want to find what cutoffs put 95% in the middle, just like we did with the z calculator. We'll do it here. We just have to set the degrees of freedom to be 22, and we put the area between to be 0.95. It will figure out symmetric cutoffs that achieve this. So let's take this critical t-value. It's 2.074. I'd have to round it to 0.4. Great. And we're done. A simple random sample is drawn. The sample mean is 19.1. The sample standard deviation is 4.6. So let's do another practice making a confidence interval. So you can just see how it's done. One sample with summary data. Sample mean 19.1. Sample standard deviation 4.6. I want to create from a sample size of 34. And I'm going to create a confidence interval at 95%. Okay. So this part's very easy. Just got to put this stuff in. 2 decimal places, 0.49 to 20.71. Let's just quickly edit that. Let's increase the sample size to 61. I think we're going to do a little bit of comparison. Let's see. The interval changes to 17.92 and to 20.28. Increasing sample size, it's going to decrease the margin of error. A 99% confidence interval at 34. So I'm going to change the sample size to 34, and I'm going to change the confidence level to 99. Compute that. So we have a lower limit of 16.94. Oops, I typed it in too much. To 21.26. So compared to part A, from part A, we had 17.49 to 20.71. The lower bound decreased, the upper bound increased. When we increase the confidence level, the margin of error increases. Okay? If the sample size is 17, what condition must be satisfied to compute the confidence interval? For a small sample size, say anything less than 30, we really need a normal distribution from our population. So the sample must come from a population that is normally distributed with no real outliers. Great. Now we've got, instead of giving us sample statistics, we've got actual sample data. We've got, what is this? A sample size of 20 numbers coming from soil samples. We want to create a confidence level interval at a 99% confidence level on the mean concentration of dissolved organic carbon collected from organic soil. So let's open this data. Oops, you can't see the menu. Make it a little wider. Open this in StatCrunch. Now it's giving us the sample stats actually. But let's just use the sample data just to demonstrate how we can create the confidence interval using the data. It's just as easy as doing it with the sample data, or sample stats. Stat menu, tstats, one sample with data. All right, select the column in var1, and we select the confidence interval at a level of 0.99. Hit compute, and you've got it. That's all there is to it. 12.52 to 22.54. That's our confidence interval. Easy as pie. And again, the way we interpret that is we would say we are 99% confident that the population mean is between 12.52 and 22.54 milligrams per liter organic carbon. People were polled on how many books they read the previous year. Initial survey results indicate that the sample standard deviation is 13.7 books. So now we're going to figure out what sample size is needed in order to establish a confidence interval for certain requirements. So there's we want to know how many subjects, which is how big of a sample size is needed to estimate the mean number of books read within 6 books at 90% confidence. Let's go to the stat menu. Under tstats, one sample, I'm going down to the width/sample size calculator. All right, so what we enter here is we have to give it the standard deviation at 13.7, and we give it the confidence level 90.90. Now we don't know what the sample mean is, but that isn't going to change what our confidence width, that's the only thing we need. We want to estimate the mean number of books within 6 books. So plus or minus 6 books. Remember, that means a width is 12 books. That's the full width of the confidence interval. So plus or minus 6 means you have to go up 6, down 6. Altogether, it's 12. Hit compute, and you have your sample size. You only need a sample size of 17 to get the job done. How many subjects are needed to estimate it within 3 books? So let's bring the width down from 12, not to 3, remember, to 6, because plus or minus 3 books means in total it's 6 books wide. That's the one thing that you have to be very careful about here. Okay, 59 books. Oh, sorry, 59 people. What effect does doubling the required accuracy have on the sample size? Take a look at that. We go from 17 to 59. Let's just check in our calculator. Let's see, how much have we increased by? 59 divided by 17. If you don't see it, it's not quite quadrupling. That's the closest that this has. That's the closest option that we have. It's approximately quadrupling. When we've rounded off to the nearest subject, it's not exactly quadrupling, but that's the closest that we have there. How many subjects are needed to estimate the mean number of books within 6 books at 99% confidence? So this is now going from 90% confidence to 99% confidence. 99, and we're going to go within 6 books. That's a width of 12. Compute 39 people. So when we increased our confidence level from 90 to 99%, we went from a sample size of 17 to a sample size required of 39. Increasing the level of confidence increases the sample size required. If you want a fixed margin of error, greater confidence can be achieved with a larger sample size. This is a textbook answer. Beautiful. So that's the nuts and bolts of doing confidence intervals in StatCrunch for population proportions and population means using t-intervals and population z-intervals. All right, great.